First, concentration. Concentration tells us how much solute is dissolved in a given volume of solution. The formula is simple. Concentration in moles per cubic decimeter equals moles of solute divided by volume in cubic decimeters. You can rearrange this to find moles. Just multiply concentration by volume, or to find volume by dividing moles by concentration. Remember the key unit conversion. 1,000 cubic centimeters equals 1 cubic decimeter. So when you're converting from cubic centimeters to cubic decimeters, divide by 1,000. When going the other way, multiply by 1,000. Next, moles calculations. The mole is the unit chemists use to count particles. 1 mole contains Avogadro's number of particles, 6.022 times 10 to the 23. The basic relationship is moles equals mass in grams divided by the relative formula mass Mr. You can rearrange to find mass by multiplying moles by Mr. or find Mr. by dividing mass by moles. Mr. is the sum of the relative atomic masses of all the atoms in the compound's formula. Use the periodic table to find those atomic masses. For example, water H2O has Mr. equals 18, and sodium chloride NaCl has Mr. equals 58.5. Now, balancing chemical equations. Balancing ensures the same number of each type of atom appears on both sides of the equation, because atoms are never created or destroyed. Follow these steps. 1. Write the unbalanced equation. 2. Count the atoms of each element on both sides. 3. Start with the most complex molecule. 4. Balance one element at a time by adding coefficients, the big numbers in front. 5. Never change the small subscript numbers inside the formulas. 6. Check your work. The atom counts should match on both sides. Look at the examples. Hydrogen plus oxygen makes water, and methane plus oxygen makes carbon dioxide and water. Finally, we have atom economy and percentage yield, 2 ways to measure how efficient a reaction is. Atom economy shows what percentage of the reactant's mass ends up in the desired product. The higher the better for the environment. It's calculated as Mr. of desired product divided by total Mr. of all products, times 100. In many addition reactions, you can get 100% atom economy. Percentage yield compares the actual amount of product you get in the lab to the maximum theoretical amount you could get. Percentage yield equals actual yield divided by theoretical yield times 100. Yields are often less than 100% because some product is lost during the reaction. The reaction doesn't go to completion, or it's hard to separate and measure everything perfectly. These concepts help us understand not just what happens in a reaction, but how efficient and practical it really is. Great work reviewing these. Keep practicing the calculations and balancing equations.